as a developer advocate for data science and MLOps at Redis. She started her career in tech with an R&D unit in the IDF, and later had the good fortune to work with and champion for cloud, big data, and ML AI technologies. Just as the wave of each of these was started, she also is a mentor at the Mass Challenge Accelerator and the founder of Lego, a cloud-based ed tech venture. In her free time, Nava enjoys cycling, four-ball juggling, and reading fantasy. Reading fantasy books. Nava, it's great to have you on the MLOps community Meetup. Let's start the show.
Yeah, Nava, it is great to have you here, and I don't want to take up any more time because we spent a lot trying to figure out this system. So now I'm just going to hand it over to you. Let's get cracking.
Okay, I was looking forward to the song, but
at the end, I'll give it to you if there's any time.
Promise. Okay, no. Cool. Okay, so thanks everyone for joining. I'm very excited to be here, with Dimitrios in the MLOps community, talking about juggling, Dr. Seuss, and feature store for real-time AI and machine learning. And this sounds like a cryptic title for a talk, but I hope it will be clear soon. We wanted me and Dimitrios to do something special because this is not a regular meetup. And so I'm Nava Levy, I'm from Redis, I'm developer advocate for AI and machine learning at Redis. And so let's start. Let's see that I can actually proceed. Yeah, okay. So we're going to talk about, start with a little introduction about juggling and real-time AI and machine learning. Then we'll discuss the challenges of deploying real-time AI ML, how to address, and we'll be sharing lessons learned, best practices, benchmarks from companies deploying successfully real-time AI ML at scale, and a brief introduction how to get started with the very popular open source feature store Feathr and the new open source feature store of LinkedIn, Feathr. Okay. And I will mention a lot of resources here, blogs, presentation, GitHub repositories. So all the links we will share also in the recording on YouTube, is either in the description or the comment. Okay, so first of all, why learn to juggle? So other than juggling being, a cool party trick, it's actually good for the brain. It stops aging or stops aging, increasing the volume of gray matter. And if you guys are familiar with it, this is actually a very good thing, to increase the volume of gray matter. It encourages a growth mindset. So you're all the time improving and learning, and you can see immediately that you practice and you improve. And on the way, you have lots of small failures. So some people think, when you, I don't know if you can see the balls here, that, juggling is just, you start and that's it. But it actually requires a lot of practice, and probably, I don't know, 1,000 times the ball will fall before you actually manage to do a proper 3-ball juggling. And so if you do workshops to kids or adults, then every time the ball falls, it's seems like a failure, but it's not. It's just one more step to success. And what I like a lot about juggling, and I guess about any other domain that you need to master, that you you need to first master the basic component. And in juggling, it's not just practicing the 3-ball juggling over and over again until you get it. It's just throwing a ball and catching, throwing a ball and catching, just this. This is, you have to practice many, many times. Once you mastered it in, or more or less in one hand, then you move to the next hand, you know, the left hand. Okay, so it's like training, serving, okay, training and production. And you just saw there was a skew, right? But you need to do it as well as you did for the right hand. And only then you can move on to 2 balls and 3 balls, etc., etc. So this is one thing. And the last thing, it's really fun. So you see she's laughing here, and I think it's 2 notches. It's actually not even balls. And speaking of fruit, oh, by the way, this is my cat. This is how you know I'm from home and not from the office. And I actually have some experience with juggling with fruit. So here I am juggling in one of the user conference in a company that I worked in the past in revenue intelligence and fraud detection. And I was doing it with Lior Manor, who is a great moderator and magician in that domain. And here I'm juggling with light emitting balls. And I'm doing it again with somebody who's much better than me. You can see him on the right and I'm on the left. And the reason it looks this way, it's because it was dark and there was a long exposure. So you could see it as a nice pattern. And again, even though we are supposed to do the same thing, we each have identical balls, maybe slightly different colors. You can see that I'm the amateur, you know, I'm much less good. It goes much less. It was very heavy for me to do this, but this was in an innovation camp, one of the companies that I worked with. And then I thought maybe I should raise the stakes, you know, maybe, you know, not just fruit or balls, maybe eggs. And this is actually with, you know, raw eggs, not cooked eggs. And so this is me juggling with raw eggs, and you probably can imagine how this ended. And so this is, you know, the stakes are higher. So maybe the data type, the data is actually more, not the data type, the data is actually more sensitive, or it's more important to have high availability and stuff. So think about that. And lastly, you know, just plain old juggling with balls. And you could say, what's the challenge in that? So maybe add another ball. So, you know, maybe lower latency or higher throughput. So this is me juggling with 4 balls. And this actually took me a very long time to move from 3 balls to 4 balls. I started juggling maybe when I was 8 or 9 years old, but to move from 3 to 4 balls, it was when I was 30 about, and took me weeks of non-stop practicing. Every minute that I had spare time, I just practiced. And eventually I succeeded, and this is another conference that I'm doing it, and you can see I'm not smiling. So you could see that this was probably very challenging for me, and that was my limit, at least for now. I'm not yet saying what will happen in the future. So in this talk, we are going to touch a little bit about the connection between juggling in the context of Feathrstore for real-time AI. And we're going to be sharing in the use cases or best practices, lessons learned, architectures, benchmarks of companies successfully deploying real-time AI ML, and it's from the vantage point of Redis. So these companies are using either Redis or Redis Enterprise to deploy the real-time AI. And you can see almost every industry. So if it's financial services, then we have Block, and we have Ekata, and we have Robinhood, and if it's and Better for online mortgages, and if it's telecom, we have AT&T and Comcast, and if it's ride-hailing, we have Uber and Gojek, and if it's food tech, then we have Zomato and Swiggy and iFood, and many, many more. Basically, these very successful companies are all deploying real-time AI ML at scale. And the nice thing about it is that they are sharing their lessons learned with the community, and so we are in a position to share it back with the community. So what is AI and machine learning or real-time AI and machine learning? So you can see here many use cases: fraud detection, video recommendation, the next video on YouTube or TikTok, loan approval or self-driving cars, speech recognitions. All of these use cases, you're probably familiar, and you might even interacted on a daily basis. And more of these use cases, we see that are becoming real time, and already real time. And when we say real time, what do we really mean? So what we mean is that we're saving prediction in real time. As soon as we receive an online request from an operational system or from an app, as the user searches the app or website, and we're using live, fresh, real-time data that is relevant for the prediction or for the scoring, not data that is old or not relevant. And we have to do it very, very fast with very low latency, because now the AI ML use cases are integrated, part of interactive application or part of an online purchase. So it has to be done in the background without the user actually knowing that it's being done, without any delay. And so this is what we call latency, delay or latency. And if I think what is the most basic component for real-time AI? So I think that the most basic component, the prerequisite for real-time AI, it's latency, because if we're not able to do the scoring or the prediction with a very short time frame, before the user even notices that there is something going on behind the scene, then we don't really have a real-time AI-based use case. So latency is the most basic component to control, and it's actually very low latency. So it's a fraction of a second, and we'll see more of it, what we mean by fraction of a second, using an example use case of fraud detection, or from fraud detection to fraud prevention. So as I mentioned earlier, I used to work in the past in a fraud detection companies 10 years ago. And then, we didn't use machine learning. It was rule-based, it was batch scoring, and maybe the window of 2-3 days or once a day was good enough. And then 3-5 years ago, the window became smaller, 40 minutes, and it's already adding machine learning. And then 2-3 years ago, we already call it online scoring, and it's near real time, between 12 seconds to 200 milliseconds. And you might say, 12 seconds isn't really real time, but 3 years ago, I actually seen a use case of a company in fintech, very successful, that showed how they moved from 40 minutes to 12 seconds. It was for a loan approval and money laundering. And for them, it was a huge return on investment to move from 40 minutes to 12 seconds, because they could move from fraud detection to prevention. But it's not 12 seconds. It wasn't integrated into a flow of a transaction, right? So now we see that the latency is between 50 to 200 milliseconds, and it's real time. And the example for companies who are doing it are AT&T and Ekata for fraud prevention. And if this sounds challenging, then this is just really a part of it. But that is not all. The end-to-end latency includes the following key sources. So there is the network latency, can be anywhere between 50 to 70 milliseconds. There is the application pipeline, and for gaming, this is a huge source of latency, but for any application, it's a source of latency. Feature serving, and this is, will be a focus of our talk. You need to extract the feature and serve them to the model for scoring, and also the scoring, it takes time. So all that, the sum of this must be less than the required end-to-end latency. But that is not all. Once we manage to do it on a single transaction or a single prediction, and assuming we are successful, then eventually the use case will have high throughput. So maybe it's 1,000 per second or millions per second, but it will have very high throughput, and that is more challenging than a single transaction. And at scale, the data set in the feature store or in the that you're dealing with could be terabytes of data. So it has to be able to scale to terabytes of data and still maintaining high accuracy. So if I said that for real-time AI ML, the basic component is latency for data science, the model, the basic component is high accuracy. It doesn't matter if it's recall or if it's a precision or F1 score, whatever your North Star is, you need to try to maintain it between training and production without any skew. And there will always be some skew, but you have to try to minimize it. So I would say for data science, we have to maintaining high accuracy. And so you're wondering, okay, I get it why Nava said juggling, but what's Dr. Seuss? So if you're familiar with Cat in the Hat, as when you were children or for your own children, then this is what he does. He juggles with all kinds of objects, and he keeps adding more and more objects. And he says, but that is not all. I can do this and that, and look at me, but that is not all. So this is like what I feel like, that machine learning engineers have to deal with more and more stuff. But if for the Cat in the Hat, it was more of a party trick to do this, he was trying to impress the readers or the kids there. For a machine learning engineer or MLOps engineering, it's not really an option. There is no option. The use case it determines a certain latency, and then when it's successful, it scales to maybe millions per second or more. And the more users that you have, the more the data set will be larger. So it's and then there are all these other requirements for observability and explainability, and so it's really endless. And we don't have any choice. So this is why I thought of Dr. Seuss, not just about juggling. And here it's like a red ball, but there are very different challenges. It's not just juggling with 3 balls and then adding another ball. Maybe it's more like really juggling with different objects that each require a different skills and different touch. So, but that is not all. So what else we have? Once that we have a use case that has high accuracy and it's in real time, it becomes much more valuable. And when it's much more valuable, then it's more and more increasingly integrated into the mission critical flow and customer facing. And then high availability is important, 4-9 ability, even 5-9 ability, highly persistence, not to lose the data. When you keep on scaling, then you want a way to easily manage and scale. And also, you want to scale cost effectively, because for high throughput, real-time use cases, the total cost of ownership of the MLOps platform can be quite substantial. So you want to also scale cost effectively. And finally, globally distributed. So it could be from latency, network latency considerations. It could be disaster recovery, or it could be regulations. So it's no wonder, I think, that we see that a lot of companies struggle with deploying machine learning, and specifically real-time AI ML. And here you can see, the cat in Dr. Seuss that eventually he didn't manage. And while for him it wasn't such a big deal, he quickly recovered. And if it was a clown or in the circus, then it might be even funny when everything crashes. But for machine learning models, really the stakes are higher, and they are higher than just eggs falling on the stage in front of live audience. So so what can we do? How do we manage to deploy successfully real-time AI machine learning? So here we have, as I mentioned earlier, we have companies that share their lessons, their best practices, their technology stacks, how they are doing it successfully at scale. And it's not just the end user, the deploying real-time AI, the companies that are doing it, they're also the providers of software and infrastructure on the right side. So for instance, the commercial feature stores, Tecton, Quark, SCADA, H2O, or the open source feature store, Feathr and Feathr, that are also deployed on Azure. So all of these companies are sharing their best practices. Some of them are publicly available, and I'm going to point you to those resources. And I think it's very nice about the machine learning community, that there is such a sharing of knowledge. And I will start with the Ekata use case. And I'm just going to move this. Not sure how I'm hiding this. Never mind. Okay, so the Ekata, if you're not familiar, it's a company, a very successful company, identity verification and fraud prevention that last year were acquired for almost $1 billion by MasterCard. And they do identity verification. And I'm going to talk specifically about the transaction risk API, in which Redis is used for the identity graph. And the requirements, you can see here the requirements, they have very stringent requirements. So the end-to-end is 100 milliseconds. This is typical for real time. And for this to happen, they need the subgraph retrieval to be 20 milliseconds. And this means that the data store or Redis latency should be less than half a millisecond. So this is, you can see that 100 milliseconds means half a millisecond. So this is really the challenge. And I think that some companies, they see the 100 milliseconds and they don't really do all the steps to understand that eventually this means that the data store, it's maybe 10 milliseconds or 5 milliseconds. Specifically for Ekata, it was half a millisecond. That's, not always the case. They have a very high, low latency, high scale use case. So the throughput, hundreds of thousands of queries per second. The data set is, more than 10 terabytes of data, and it has to be highly available and stable. So these were the requirements of Ekata. And to do that, they implemented the identity graph using sorted sets, or Redis sorted sets. So this is an example how Redis is not just a regular key value store. It's actually a key data structure, a server or database, and it supports many types of data structures. So it could be lists, sets, sorter set, JSON documents, time series, strings, streams, basically any data structure that you can think of, Redis supports. And depending on your use case, you might find it valuable to experiment and choose the right data structure. So for Ekata, they use it's a sorter set, other use hashes, Redis hashes, other use JSON, etc. And what Ekata said that to be able to meet those stringent requirements, they had to be powered by the fastest and most reliable tech stack in the market. So Redis is part of this tech stack. Of course, it's not the only thing. And this enabled them to scale to any low latency, high volume model requirements. And here we have the AT&T use case for the prevention. So they have a feature store that they developed internally called Atlantis, and you can see that they're using Redis for the online store, for the online scoring. And the latency requirements are 50 milliseconds latency, so the data store, it's much less than that. And by the way, the Atlantis feature store is also the basis for H2O feature store, which they did jointly together. So this is also very interesting. And again, what are the requirements from the stack for the online store is lightning fast, high scalability, high availability. And so if we look at the data pipeline for real-time AI/ML, so we have the data, the raw data on the left, and it could be batch sources, and it could be streaming sources like IoT sensors, and maybe it's a click stream or a server log or transactions. And you need to take these data sources, the batch sources and the streaming sources, and do what we call feature engineering to create features out of them. And then you store them in typically an online store, typically an in-memory online store for low latency. Then you need to extract those features and serve them to the model for prediction. So in any of those components, you can any choice that you make will improve the latency or vice versa. So for feature engineering, what are you using? Are you using, what using for streaming? What are you using for processing, computation? Is it Kinesis? Is it Spark? Is it Flink? So any choice that you make will have implication. What are you using for feature serving? Is it a Java gRPC server? Is it a Python HTTP server? Maybe it's an AWS Lambda function. And for the serving, which engine are you using? Is it of NVIDIA? Is it TensorFlow serving? Are you using hardware accelerate? Maybe it's GPU, TPU. All of them are, every choice will have an effect on the latency. Also, maybe you can make the model smaller, and that will also reduce latency. But what we found that has the most effect or has the most room for optimization, or maybe it has the biggest source of bottleneck, is the online store, the data store for online service. It's called online store or online feature store, not always. Sometimes our customers just say, yeah, we use Redis for for online serving the features, or serving the features for online model scoring. But more recently, in the past 2-3 years, companies are actually see it as a separate category called online store, online feature store. And it's becoming a critical component of the real-time data layer for machine learning and AI. Okay, so why is Redis selected for the online store? So the reason is benchmark, and here you can see benchmark from Uber, from Feathr, Tekton, and DoorDash. And so for you can see that Uber basically saying that they chose Redis over Cassandra for certain use cases, data sets, because it's much more cost effective. So I think this is not so intuitive. Often people think, okay, Redis is very good in terms of performance, but it's much more expensive. So actually, it's the opposite. If you have a given latency and a given throughput that you have to comply with, then Redis will be the most cost efficient. And Feathr did a benchmark comparing other data store and also found that Redis is the most performant. Tekton compared the DynamoDB to Redis Enterprise and found that Redis is 3 times faster and 14 times less expensive. And this is huge, right? 14 times less expensive, again, for either low latency or high throughput use cases. And also DoorDash compared to Redis to several key value store and found that it's the highest throughput, low latency, and the most cost efficient. And this is really because Redis is an in-memory versus a disk-based. Okay, so this is and here are links to all these benchmarks. You're welcome to to read them and dig deeper and see how they came up to those results. And recently there was the Apply conference that also Demetrius was the host, and there was a really interesting case study of Block, how they use for Block's cache-up real-time machine learning ranking and personalization, and they explain how by moving from a disk-based to in-memory based data store, they really shifted the entire latency curve. So this is really what it means to move to an in-memory database, to Redis. It shifts the entire latency curve. And you can see how the latency dropped. But like everything, you have to also look at the details, and there is additional room for improvements. After you choose Redis, there's still room for improvement. So for instance, DoorDash have a blog post that you have the link here that explains how by moving from a flat key value pairs to a data structure that calls Redis hashes, they were able to significantly improve the latency, CPU efficiency, and memory footprint, and this translates to reduction in cost. So instead of having multiple get comments for each key value or number of room, number of bedroom, every feature is a key. You use Redis hashes and you have a single command hm-get to fetch the entire vector. And if a vector could be tens of features or hundreds of features or thousands of features, this is really significant because and it has an effect of read latency dropping by 40%, 5x improvement in CPU efficiency. And so this is why it's really important to look at your use case and think what is the best data structure to use, and Redis supports all. Now, DoorDash started, as many companies, with the online store as the key component of the feature store for real time. But over time, the online store together with the offline store became a new logical component that is becoming very important for machine learning operations. And the offline store is for model training and batch scoring, and the online store for online serving. And the online feature store, it stores the latest feature and it has to serve very fast features for online prediction. But the offline store, it's training and batch predictors. There is no latency requirements, so it stores the static and historical data. So if the online feature store is implemented with Redis, the offline feature store, we see it could be Snowflake, like in the case of DoorDash, but it could be also Redshift and S3 and BigQuery and Azure. And I talked about the storage, but there is also a management orchestration layer that is in charge of the registry to registering the features, the transformation logic and monitoring, and over time more and more capabilities are added to the feature store. So if you think of the key objective of a feature store, so serving features for real-time prediction with low latency, we talked about it at length, but it's also about avoiding training serving skew, and this has to do with accuracy. So we had, on the one hand, we had the latency aspect, that was the basic component for real-time AI, and we had the other one, which is keeping high accuracy. So we do it by avoiding the training serving skew, and the feature store helps by defining the feature on a logical level in the registry. All the transformation, data sources, everything is there. And once we define it on a logical level, we can use this definition once for training and once for production, for serving. This helps us avoid this skew. Now, an added benefit or side effect of this, once these features are defined in the registry, then we can reuse them for other use cases, or another data scientist can use it also for his use cases. So this is the third objective, allowing data scientists to share features between machine learning use cases, and it's very, very important. It's not so important for real time, but it's important in general for MLOps, because as you probably know, that more than 50% of the time data scientists spend on feature engineering and data management. So why reinvent the wheel? If you have one feature that can be reused across several use cases, it makes a lot of sense to do that, and the feature store helps us do it. And for real-time AI ML, the first two are very, very important. And here are a number of architecture for feature store. So on the top left, it's the open source, a very popular open source feature store Feast. On the right side, on the top, it's Wix, which is a do-it-yourself feature store, a very successful company that builds, helps anyone, small, medium business build website without coding, and has 200 million users, and Tecton, which is a commercial enterprise feature store, and Quack, which is also a commercial feature store. And I'm going to share a few. Let's see how we're doing with time. Okay, I'll do it very quickly, but the details, there is a KD Nuggets article, feature store for real-time AI and machine learning, that has the details, but each one is implemented slightly differently, and it has a lot of implications in terms of their performance and cost. So this is the Feast data infrastructure, and they materialize the features from the offline store to the online store, as well as from streaming sources supported for Redis. It's not so, and one of the reasons that it was so easy for Feathr to support streaming sources with Redis is because of the TTL, time to live, that is built into the Redis database. So you can have a feature time to live and expire features that are already stale and evacuate them from the online store so they don't take up valuable storage. So this is the Feathr feature store, and again, the features are materialized from the offline store to the online store. And then we have weeks that only materialize from the offline store to the online store. The users that are become online, that are logging into the Wix website. So if they have 200 million users, but only, let's say, 1% are logged in at any given time. So this is like a huge saving in terms of how many features are stored in the online store, but it has the disadvantage that the warm-up process takes a few seconds. So if there is a racing condition, due to racing condition, that a model is being triggered, but the data doesn't exist in the online store, then the prediction will fail, will not happen. So it's good for use cases that it's not really critical. It's not good for fraud detection, but it's very efficient, and it's an subtle how a feature store architecture was built to address the very specific circumstance of Wix that only a small subset or very small subset of the users are logged in at any given time. This is Tekton. So Tekton, you can see that this is, by the way, they also support DynamoDB, but this is from the press release that they are now supporting Redis Enterprise due to the need of their customers to support a low latency or a high throughput use case cost effectively. And you can see here that they support batch sources, streaming sources, and also real-time features, which are features that the data can be known only at a server request. And so this is very important to support it out of the box. For instance, Feathr don't support it out of the box. It doesn't mean that you can't implement real-time feature, but you will have to do it yourself. And here Tekton does it for you. So it's very, very useful. And last, it's the Quack feature store. And they also support, batch sources, streaming sources, and real-time transformation. But what's interesting about Quack is that the data is loaded to the online store, which is Redis, directly from the raw data and not from the offline store, contrary to the other three feature stores that I just mentioned. And so this has an advantage of really having not just a unified logical definition of feature, but the actual transformation computation is done uniformly. It's a unified pipeline for training and serving. And just to wrap up, we're using the Ekata case study. So all the balls that you see here are the key considerations or requirements for deploying real-time AI machine learning at scale. So we talked about throughput, latency, scale, different types of structures. Here, you can see the very important aspect of scaling cost effectively. So once you have a data set is larger than, more than 1 terabyte, then it makes a lot of sense to leverage Redis on Flash of Redis Enterprise. We see more and more companies do that, saving hundreds of thousands of dollars on an annual basis. So it's basically a tiered memory access. And because we see that more and more high-scale feature store are moving to it, I did add a slide to explain a little bit more about Redis on Flash. So what we do is we store the keys in memory, in the RAM, but we only store the hot features in RAM, and the warm features we store on SSD or Flash. And this has a potential to reduce cost up to 80% without compromising latency and it's completely transparent to the user or to the company. So if you're running on Redis Enterprise or Redis Elastic Cache and you want to move to Redis Enterprise with Redis on Flash, you can do it, including the proof of concept. You can do it in 2 weeks. And we actually have examples of customers, sending us an email, and 2 weeks later they have in production Redis on Flash, and they're saving hundreds of thousands of dollars to the company. And this is substantial because the online store can be 50% of the total cost of ownership of the MLOps platform. So if you can reduce the cost, it's very, very good. And last but not least is that we just made Redis on Flash even better, almost 4 times faster. And there is a blog here, a link to the blog that you can see how we did it. So it's just getting better and better. So the hundreds of thousands of dollars saving that Ekata saved and other companies is just the beginning. There is more room for saving. So we talked about scale cost effectively. Also, you can see how Ekata used the Redis Enterprise to gain high availability. They talked about 4.9 availability, and Redis Enterprise supports 5.9 availability, and we know that banks, for instance, it's important for them, 5.9 availability, and multiple availability zones, so it's globally distributed. And finally, by using Redis Enterprise Cloud, you can gain a fully managed solution. Often people think, okay, Redis is great, but maybe it's difficult to manage the clusters yourself. So if you don't want to manage the clusters yourself, if you can and you have the in-house capabilities, and this is what you want to do, sure, go ahead. But if you don't want, you can just use Redis Enterprise Cloud, and it's a fully managed solution with 24/7 support, 5 nines availability, with active, and much more. And okay, so the last part, let's see how we're doing in time. Okay, so the last part I will go very quickly is just, you've seen all this and you want to get your hands-on and start seeing what is this all about, feature stores with Redis. So you can just go and use one of the 2 open source feature stores, Feathr or Feathr. And Redis is also open source, so you can just do it 10 minutes after this talk and try yourself. So we talked a little bit about Feathr before, and it also supports streams with Redis. Here you have a tutorial. We put together a tutorial. It's also available on Colab, and it walks you through all the steps, how you can do it yourself. And the cool thing about Feathr is that it's a really lightweight feature store. So even if you're not even an MLOps engineer, you're a data scientist and you're the only data scientist in your organization, you can still do it. You can run it locally. You don't need to deploy, a lot of infrastructure. Now, if you're already using Azure, you're an Azure customer, then Feathr is also available on Azure. It's integrated with the Azure Data and AI ecosystem. And there is a great tutorial, which you see the link below here, on how to use Feathr on Azure. And Feathr, LinkedIn Feathr, which is the new kid on the block, it's a new open source feature store. Let's say it's a new old, because it has been battle tested by LinkedIn for 5-6 years, but they only recently open sourced it. And it's also available on Azure. There is also a Slack channel that you can subscribe to it. And if you have questions, you can ask there, and the community will support you. Both Feathr and Feathr support Azure Cache for Redis with enterprise tiers and Redis and Flash tiers, which is similar to Redis on Flash. So this is really cool. You can get the 5.9 availability, the cost reductions, and everything. And there is also a quick start tutorial for Feathr. So this basically summarizes my talk. We talked about a little bit about juggling. We saw how juggling and Dr. Seuss relate to MLOps engineer. Mentioned that contrary to Cat in the Hat, that for him, what's the big deal that everything crashed on the floor, or juggling with eggs, just a little bit of mess that you quickly clean up. That's actually what we had to do. But for real-time AI ML, it's actually serious stuff. You don't want the data to be lost, don't want downtime. You don't want to have latencies, you don't want to have a bad customer experience, and you don't want, let's say, if it's fraud prevention, to allow fraud. So all these reasons, you need a stack that is built for scale and for speed and that is robust. And we talked about the role of Redis in it. Thank you for listening.
Amazing. Do you have any specific do's and don'ts for using Redis on AWS in a microservice setting?
So if I have do's and don'ts regarding using again, Dimitri?
Using Redis on AWS in a microservices setting. This one's from Chris. Great question, Chris.
Yeah. So I don't have any specific, but do's and don'ts, but I can get back to you on this. I'll ask for one of our cloud solution architects of Redis. But generally, AWS, you can run open source on AWS. You can go with Redis Enterprise, and there is also Elasticache, but Elasticache doesn't support Redis on Flash. It doesn't support many of the data structures that we have. It doesn't have the cost efficiencies that Redis has. So it really depends how you're using Redis on AWS. But AWS is great, and yeah.
Excellent. All right. I am terribly sorry, everyone, about the technical difficulties that we had at the beginning. Thank you, Nava, so much for this. I am going to record a special song for you and put it on LinkedIn or something. And if anyone else has any questions for Nava, feel free to reach out to her. She is on the MLOps community Slack. And that is all. I see there is another question coming through from you, John. John, I got to jump, but let's take this to the MLOps community Slack. That is a great question about Redis on Ray. So Nava, I'll let you answer that, or John, just tag Nava in MLOps community Slack, and then we can go from there. So thanks, everyone. And sorry again about the technical difficulties. We'll be back again in a few weeks, actually. I think we are having Tekton present in a few weeks. So if you liked the feature store chat, then keep your eyes peeled, because we are going to be doing another one of these. And hopefully by then, fingers crossed, the stream actually works and we can do it on the cool platform that we've got. All right, everybody. Feel free to reach out to me if you have any questions or anything. And thank you so much. See you all later.
Thanks, Demetrios. Bye, everyone.
Thank you, Nava.